All right, welcome back. We're going to talk about binomial expansion a little bit more here. Um, just one last thing that's going to make your life pretty easy for the second part of the homework. All right, now we've been talking about Pascal's triangle, and whoops, want to help you understand where we can find some of these terms and the notation that we use for them, so that on your calculator, if you had to do like the 10th row or something, you could do it without having to draw the whole triangle. All right, as I mentioned earlier, we're going to call this the second row and the third row because this has the 3 in it. And this is the first row, and this ends up being the 0th row. Okay. Um, for similar reasons, we call this the 0th element. These are going to be the first elements, 1, 2, 3, 4, 5, second elements, third elements, and fourth elements. So it seems kind of weird, but you'll understand in a minute when I go through this why this works. Because the second row here, this is element 0, element 1, and element 2. All right, now, turns out that we can get each of these elements, an individual element here, like let's say I want to find this 3, by using a button on our calculator called the combination button. Some of you may have seen it. It's the NCR button on our calculator. It's under Math, PRB. If you go to the Math button and move all the way to the right and or one space to the left, you'll see an NCR. And you're going to put in the row. This is the third row. And this is the first element. Now remember, this is the first element. This is the 0th and the first. And if I take a minute and plug this into my calculator, 3 NCR1, the calculator will give me 3, which is exactly what I'm looking for. And if I wanted to find this element here, this is the 5th row. It's obvious that it's the 5th row. Okay, and this is element 0, 1, 2, 3. So I go 5 NCR3, and that will give me 10 on my calculator. All right, this is going to be useful to us when we take some shortcuts, because the next thing we're going to do is look at some patterns within our expansions and use that to our benefit in solving these problems. All right, so some things to note here. Here's Pascal's triangle row 5. And as we've learned, we could call this 5 NCR 0. Okay, now the mathematicians don't write the N and the R. That's calculator notation. So we could call this 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. Some things to note. These are symmetric. 1 and 1, 5 and 5, 10 and 10. Okay, so that's going to be important to note. How can I tell which ones are symmetric? Well, it's the first term and the fourth term are the same. The second term and the third term are the same. The 0th term and the 5th term are the same. What are those ones in common? All have in common themselves. 0 plus 5 is 5. 2 plus 3 is 5. 1 plus 4 is 5. That always works that way. So for example, 8 choose 3 will be the same as 8 choose 5 because the 3 and the 5 both add up to 8. All right, so that's one pattern we should notice. A next pattern we should notice. What can you tell me about these two exponents? The exponents always add up to 5. Interestingly enough. Okay, and this number here, 5 choose 4, that's an exponent. 5 choose 3, that's an exponent. 5 choose 2, that's an exponent. That happens to be the exponent of y, but remember, these are symmetric, and I can use either exponent here. That's kind of fast. Let me go through this again. I could have put 5 choose 1 or 5 choose 4. It didn't matter. These are the same. These are both 5. And here's my 1 and here's my 4. All right. Why am I telling you all of this? There will be times where I'll give you a problem like this. And you're going to think to yourself, oh my God, 18 will take forever. Yes, it will. But then I will add a second part. What term contains x to the 7th? I'm only looking for one term. So think about what this means. If I were doing this all the way out, I would have 1, 18. I have no idea what the rest of this is. Okay? I don't know what Pascal's triangle is that far out, but we don't need the whole thing. We're only going to need one term. Then I'm going to have x to the 18th, x to the 17th, x to the 16th, okay, all the way down to x to the 0. And somewhere along the line, I'm going to have x to the 7th. Okay? Meanwhile, my y's are going to start with 0, 1, 2, and there's going to be a y here. Now, I don't know what this number is, but I know it's going to look like this. 18C7. How did I know that? I just showed you. Back here, we showed you that this, I can use either of the exponents, will be the subscript on my combination. So I have 18 choose 7. And how can I get this value? What did I tell you about these two? These two together must add up to 18. So this has to be an 11. So if I get my calculator out, and I go 18 math PRB number 3 7, I get 31,824. So this is 31,824 x to the 7th, y to the 11th. That is the term that contains x to the 7th in this expansion. Let's do one more example, and then you can try these in the homework. Let's say I have 2x minus y to the 13th, and I want to know what term contains y to the 5th. Okay, so I've got three parts to this. I got to fill in this blank, and I got to fill in those exponents. So I'm looking for y to the 5th. That's easy. These two have to add up to 13, so this must be an 8. And this one can be either of these exponents, 8 or the 5. It'll be the same answer. 13 choose 5 is fine. So now I can go to my calculator. 13 choose 5 is 1,287. Here I've got 2 to the 8th. Remember, we have to distribute this. And a negative 1 to the 5th, which I know is negative 1, times x to the 8th, y to the 5th. If I'm going to clean all this up, 2 to the 8th is 329,472. 329,472 x to the 8th, y to the 5th. And that is the term which contains y to the 5th. All right, you have homework for tonight. It involves both the types of problems that I've covered in these videos. Try them. I think with a little practice, you'll come to see that they're pretty straightforward. There's also more questions like this in your review packet. All right, good luck.